As you've probably guessed, this week we'll be talking about equations. I'll start out by talking about one-step equations, and then we'll ease into two-step and multi-step equations as this video progresses and also as the week progresses. Please note that you'll have a quiz on Friday. That's very important. Okay, quiz on Friday. So let's start out by talking about what an equation actually is. Okay, an equation is a statement that two expressions are equal. So notice that x plus 3 is an expression. It represents a number. And 8 is also an expression. Okay, it's a statement of equality between these two expressions. Okay, so here we know that x plus 3 is the same as or equal to 8. And one good way to think about an equation is that an equation is essentially a balance beam, right? So this equal sign balances both sides of the equation. Before we even begin, I want to talk about integers for a minute, because you'll be using a lot of them for the remainder of the semester, and the year really. So let's talk about adding. Okay, adding is more difficult than multiplying, so we'll get the hard stuff over first. So when the sign's the same, for instance, 2 plus 3 is equal to 5. We knew that since first grade. The sign's the same, so both 2 and 3 are positive, so therefore your answer is positive. Same goes with negative integers. Negative 2 plus negative 3 is the same as negative 5. Okay? So this is a negative 2 and a negative 3. You'd ask yourself, well, negative 2 and negative 3 are both negatives. We're adding, so therefore I'll keep the sign, and my answer will be negative 5. You can think about this also as owing your buddy $2 and then owing them 3 more. In all, you owe them $5. Okay? One thing I want to point out, too, is that negative 2 plus negative 3 is the same thing as negative 2 minus 3. The only difference is that the first one is written with a plus sign, and the second one's written with a subtraction sign. Okay? Every time you see a subtraction sign, I want you to keep, change, flip. In other words, keep this negative 2 the same, but then change subtraction to an addition sign, and flip, or find the opposite of negative 3, which is 3, which is negative 3. So you realize here that negative 2 plus negative 3 is the same thing as negative 2 minus 3. You end up with the same answer of negative 5. So I'm going to write in red. Actually, I'm going to erase this for now. I'm just going to write the basic rule here. When the sign's the same, you add the numbers. And keep the sign. I apologize for my terrible handwriting. It's just the way that it writes on the smartboard. Okay, so now let's talk about when the signs are different. This is where it gets a little bit trickier. Okay? So when the signs are different, it's like having, it's the same as, I suppose you owed your buddy Billy $5, but then you gave him $3. You're still in debt to Billy, right, by $2, but by not as much as before. So when the signs are different, you subtract the numbers and then keep the sign of the one with the larger absolute value. So in this case, negative 5 has a larger absolute value than 3, so you would subtract the numbers. 5 minus 3 is 2, but you know that negative 5 has a larger absolute value, so your answer would be negative. So here's another example. 7 minus 8. We never subtract, so we keep change flip, right? Subtracting is the same as adding a negative. The signs are different. 7 is positive, negative 8 is negative. So we subtract the numbers. 8 minus 7 is 1, and then keep the sign of the number with a larger absolute value. So negative 8 has a larger absolute value, so our answer will be a negative. And I'll do one quickly where it will end up as a positive. Suppose we had 10 plus negative 3. The signs are different, so we subtract the numbers. 10 plus negative 3, we get 10 minus 3 is 7, but 10 has larger absolute value, so it'll stay positive. So let me write down the rule. When the signs are different, subtract the numbers. And keep the sign of the number that has a larger absolute value. Remember that absolute value is the number's positive distance from 0 on the number line. Okay. Now, when the signs are the same, when multiplying and dividing is so much easier. You're going to love it so much more, okay? When the signs are the same with multiplying, for instance, 2 times 5. Let's see. We get a positive 10. So the signs are the same. It's positive, always. Okay, so that goes with negative 2 times negative 5. You'll end up with a positive 10. Now, so that's simple. I'm just going to write that at the bottom. Multiply and make it positive. You can also think about this as if you have an even number of negative signs, then your answer will be positive. Okay, when the signs are different, that's when it's negative. So if we had negative 5 times positive 3, we'd get a negative 15 because the signs are different. Okay, we could even flip that. We can get 5 times negative 3, we'd still get negative 15. So when the signs are different, you multiply or divide. It works either way. Multiply and make your answer negative. Okay. Now that we've reviewed that, I want to talk briefly about what this is. This whole thing, this whole statement right here of 7x plus 3, this whole thing should have been an arrow. Okay. This whole thing is called an expression. What separates this expression from an equation is the equal sign, right? So this is an expression, but let's talk about the 3 things that we see here. This 7 is called your coefficient. It's the number being multiplied by the variable. Which leads us to the variable. The variable is x in this case. That's what we don't know. And this right here, let's see. I'll use black. I like to include the sign, okay? This is called your addend. It's what's being added, essentially. Now, if it was minus 3, then your addend would actually be negative 3. So notice that I circled the plus sign as well. You'll need that when solving equations. All right, so one step when adding. When you're solving a one-step equation and you're adding, the one step is to add the opposite of the addend. to both sides of the equation. Add opposite of the addend to both sides of the equation. So, for instance, here we keep, change, flip, right? Keep, change, flip. We know that our addend is -5, so we add the opposite of it to both sides. The opposite of -5 is +5. Okay, we're left with just an m on the left side of the equation, and then 17 plus 5 will land us at 22. Okay, so that's how you solve a one-step equation. Just add the opposite of the addend to both sides of the equation. Pretty simple. One thing to point out, I have two things actually. This right here, the statement that -5 plus 5 equals 0 is actually called the inverse property of addition. I'm just going to write inverse right here. Okay, that's really important to know. Okay, so we're using a property in order to solve this equation. And also the fact that we had to add 5 to both sides of the equation, that is because of the equality property. Okay, meaning what you do to one side of the equation, you have to do the other side of the equation. Okay, so now let's work on multiplying. So the one step with multiplying is to multiply by the reciprocal of the coefficient to both sides of the equation. Now remember, the reciprocal is just that number flipped, okay? So for instance, the coefficient in this case is 3. 3 is the same as 3 over 1. The reciprocal of 3 over 1 would be 1 over 3. It's just that number flipped upside down in a fraction. So let's multiply by the reciprocal of the coefficient. Reciprocal of 3 over 1 is 1 over 3. I'm going to do it to both sides of the equations. All right. Then we simplify. Okay, a third. 3 and 3 share a factor of 1. It looks like we're just left with 1m. And that is equal to, okay, so 3 goes into -15, -5 times. So that means our answer would be m is equal to -5, or -5 is equal to m. I'm going to point out the properties again. This property right here, we had 3 over 1 times 1 over 3, and that's equal to 1. This whole thing is called the inverse property of multiplication, meaning a number times its reciprocal is equal to 1. And then notice again we had another equality property where we multiplied by the same thing to both sides of the equation in order to keep things equal. All right, two-step equations are just combining those two steps in that order. First step, we work with the addend. So we add the opposite of the addend to both sides of the equation. And the second one is we multiply by the reciprocal of the coefficient to both sides of the equation. All right, so here I see that 2 is what's being added, so that's your addend. We're going to add the opposite of 2 using the inverse property of addition. Okay, so now we're left with just a over 4 on the left side of the equation, and then 6 plus -2. Okay, the signs are different, so we subtract. 6 minus 2 is 4. 6 has a larger absolute value, so our answer will be 4. And then we multiply by the reciprocal of the coefficient. Okay, this is where it gets a little tricky because you can't outright see the coefficient of a, okay? But we do know that there is a coefficient in front of a. It's a phantom, you can't see it, 1, okay? If you were to pull this out here, you're left with a fraction of 1 over 4. So really the coefficient of a is 1 over 4. So let's multiply by the reciprocal of that, which is 4 over 1, to both sides of the equations. I'm not going to write 4 over 1 on this side because we don't need to. All right, notice again, inverse property of addition happening and the equality property. 4 times 4 is 16. So we're left with A is equal to 16. All right, this one's pretty similar. I'm going to move on to this one. Okay, so we never subtract, so the first thing we would do before we even start solving this equation is we keep, change, flip. The addend in this case is -7. First step would be to add the opposite of the addend. So let's add, the opposite of -7 is 7, so let's add 7. We're left with, using the inverse property and equality property again, we're left with 9x on the left side of the equation and 0 on the right side of the equation. All right, just to go through the steps, we're going to multiply by the reciprocal of the coefficient, which is 1/9. And 0 times 1/9 is always 0. Anything multiplied by 0 is 0, according to the zero property. And that's about all I really want you guys to do today, besides these 2 word problems. Let's do this one together. Okay, so 331 students went on a field trip. 6 buses were filled, and it's going to underline as we go along. 331 students went on a field trip. 6 buses were filled, and 7 students traveled in cars. How many students were on each bus? We don't care about people traveling in cars, right? We do know that 331 students went on this trip. 7 of those students drove in cars, and then we had the last, which was, there were 6 buses, right, for the rest of the students. Okay, so B would be the number of students per bus. All right, so here, this is our coefficient variable addend. So let's start with the addend. Let's add the opposite of 7. Okay. Which will land us at, I think, let's see, so 324. All right, then we multiply by the reciprocal of the coefficient. All right, move this guy. So let's see, 6 divided by 324. We'll do that over here. 6 goes into 32. 5 times minus 30, 24, so 4. So that means 54 would be the same as B. So you would label it as 54 students. And that's about all we have time for today. I know it's kind of a long video this first time, but just bear with me. They'll get a little more efficient as I become better with this program. So thank you so much for listening, and I'll see you in class tomorrow. Make sure to finish up the Mathletics. You'll have until, I guess I'll give you till until the quiz day, but be working on the Mathletics assignments. Thank you.